Hello all, Aakriti Educations brings you the analysis on previous year IIT-JEE questions. In this video, we will discuss question number 9 of section 2 asked in Advanced Paper 2 2020. Question says, let F maps from R to R and G maps from R to R be a function satisfying f of x plus y is equal to f of x plus f of y plus f of x times f of y, and f of x is equal to x times g of x for all x belongs to R. If limit x goes to 0, g of x is equal to 1, then we need to find which of the following statements are true. This question deals with the differentiability of function f of x and g of x. So to go with the differentiability, first we will have to deal with continuity of the function. Continuity of function f of x at x is equal to a is defined when f of a is equals to right hand side limit of f of a is equals to left hand side limit of f of a. The right hand side limit of f of a, which is nothing but f of a plus, is defined as limit h goes to 0 f of a plus h. By using the definition of given functional equation, we will write f of a plus h as f of a plus f of h plus f of a times f of h. On further simplifying, we will get f of a plus is equal to f of a plus 1 plus f of a times limit h goes to 0 f of h. In similar fashion, we will get f of a minus as f of a plus 1 plus f of a times limit h goes to 0 f of minus h. Both the limiting values of function are depending upon the value limit h goes to 0 f of h, which can be found using the definition of f of x is equal to x times g of x. So limit h goes to 0 f of h is equal to limit h goes to 0 h times g of h. On further simplifying, we will get the value as 0. By substituting the value, we will get f of a plus is equal to f of a and f of a minus is equal to f of a. Since both the values are equal, so function is continuous at point x is equal to a. Since the chosen number was arbitrary, so the given function is continuous for all the values of x belongs to R. Now, function is continuous, so we can talk about the differentiability. A function f of x is said to be differentiable at x is equal to a when right hand side derivative is equals to left hand side derivative is equal to slope of function at x is equal to a. Now, the right hand side derivative can be defined as limit h goes to 0 f of a plus h minus f of a divided by h. By using the functional equation, we can write f of a plus h as f of a plus f of h plus f of a times f of h. By using the value and further simplifying, we will get right hand side derivative as 1 plus f of a times limit h goes to 0 f of h divided by h. Now, f of h can be substituted as h times g of h, and on further simplifying, it will give as right hand side derivative is equal to 1 plus f of a. In similar fashion, we will get left hand side derivative as 1 plus f of a. Since left hand side derivative is equal to right hand side derivative, so function is said to be differentiable at x is equal to a. Since the chosen point x is equal to a is arbitrary, so the function is said to be differentiable for all the values of x belongs to R, and it will satisfy the differentiable equation f prime of x is equal to 1 plus f of x. Further, this differential equation is linear in nature and it is of order 1 and degree 1. So, by writing it in its standard format, we will get f prime of x minus f of x is equal to 1, which can be solved using the integrating factor. The integrating factor of this linear differential equation is e raised to the power minus x, and thus the general solution of this differential equation can be found as f of x is equal to minus 1 plus c times e raised to the power x. Since f of 0 is equal to 0, so by substituting the same we will get c is equal to 1, and thus it will give particular solution as f of x is equal to e raised to the power x minus 1. It can easily be verified that this function is differentiable for all x belongs to R. Further, it will give f prime of x is equal to e raised to the power x, and hence f prime of 0 is equal to 1 and f prime of 1 is equal to e. Now we check the continuity of function g of x. G of x can be written as f of x divided by x, which is nothing but e raised to the power x minus 1 divided by x, which is defined for all the non-zero real values. It can also be verified that the limit of this function as x goes to 0 is equal to 1. Further, if we have given the additional information that g of 0 is equal to 1, then g of 0 is equal to z of 0 plus is equal to z of 0 minus will be equal to 1, and hence g of x is continuous at x is equal to 0. Other than x is equal to 0, the g of x is defined as e raised to the power x minus 1 upon x, which is continuous function, and hence g of x can be defined as e raised to the power x minus 1 upon x when x is non-zero real values and 1 when x is equal to 0. So g of x is defined for all the real values of x and it is continuous throughout the domain. Hence, we can talk about the differentiability of g of x when g of 0 is equal to 1. Now, the right hand side derivative g prime of 0 plus is written as limit h goes to 0 g of h minus g of 0 divided by h, and by substituting the values it will give limit h goes to 0 e raised to the power h minus 1 minus h upon h square. Here we will use the expansion of e raised to the power h, which is nothing but 1 plus h square by 2 factorial and so on. And by applying the limit as h goes to 0, it will give half. And in similar fashion, the left hand side derivative g prime of 0 minus will be equal to half. Since both left hand side derivative and right hand side derivative at 0 are equal to half, so g of x is differentiable at x is equal to 0. And thus g of x is differentiable for all x belongs to real numbers. Thus 1, 2 and 4 are the correct options. Thank you all. If you find this video interesting, please like, share and subscribe our channel for more updates.